These are the answers to the 1.1 practice questions. So I decided to grade this for completion rather than if you got the answers right, because this is the first time you're seeing these questions. These are actual IB questions from an IB bank, question bank. So we'll go through these. For multiple choice, those are typically worth 1 point each. So number one, a red blood cell is 8 microns in diameter. If drawn 100 times larger than its actual size, what diameter will the drawing be? So you just take the magnification of 100 times 8 microns and you get 800 microns, or if you change that into millimeters, you move the decimal to the left 3 spots, 1, 2, 3, and you get 0.8 millimeters. If a mitochondrion has a length of 5 microns and a student's drawing is 10 millimeters, what is the magnification? So magnification equals the size of the image over the actual size of the specimen. The trick here is to convert them so they're both in millimeters or microns, and I decided to go with microns. So, that's a typo here. There. So the answer is D, 2000. Okay, had a lot of questions about this. It's not a great picture, and you don't even know what you're looking at. Basically, it is a mitochondrion, and you can tell because it's got the finger-like projections inside. D is a nucleus, likely, but the others don't even really know what they're pointing to. What you need to know is that it's usually going to be in a mitochondrion if they ask you to look at the cell part. And mitochondrions are the ones that make ATP. So if you knew that mitochondria make ATP, and you knew that mitochondria had the finger-like projections, you could deduce A. Okay, for this one, I told you that if you measure the scale bar, it's 20 millimeters. And if you measure the diameter of a pore, that was 10 millimeters. That was to help you guys out. So calculate the magnification. The scale bar is 20 millimeters. If you convert that into microns, it's 20,000 microns. And the scale bar represents 0.2 microns. So magnification equals 20,000 divided by 0.2 equals 100,000 times. Now, I did get some answers that were in decimal points, like a 0.15 magnification. If it's going to be less than 1, like a decimal, that means that the image you are looking at is much smaller than in real life. And the only time I think we've had that is when we were looking at the picture of the ostrich egg and the hen egg. Those images were much smaller. Usually in biology, we're looking at an image that is blown up. So the magnification is going to be a large number. And when you're looking at a nuclear pore, that's going to be quite a big magnification. So state the diameter of the pore labeled at X. Well, if we know that 100,000 is the magnification, and it measures 10 millimeters or 10,000 microns, you do 10,000 divided by 100,000 and you get 0.1 microns. Oh, I wanted to draw your attention to these numbers on the right side of the page where it says 1, 1, 1. That's how many points it's worth. So in IB, you have to give that 1 point. If it's asking you for one thing and you list 2, I'm only going to grade the first one. Okay, I don't grade anything after that. So here, B lists 2 examples about human life depends on mitosis. It is worth 1 point, but it's asking you to list 2. You have to list 2 things to get that 1 point. So the main ones were for growth, repair damaged tissue, and I did not put this. Let me write it in here. Embryonic development, you could have said. Describe the importance of stem cells in differentiation. If we look, it's worth 3 points here. That means you need to list 3 things. So the answer is